everyone, I hope you're enjoying your snow day and hopefully what is the end of a 6-day weekend. We have a lot of work to do this week and we will only see each other on Friday during class, so I wanted to make sure that you got your video lecture and that you were ready to go. So today we're going to talk about real-world integer expressions, and the learning goal has to do with rewriting expressions in different forms so that you can think about how the problem is working. And you'll see some examples that will help you to figure that out. We're also going to solve multi-step real-life problems with positive and negative numbers. Part of this learning goal today talks about fraction and decimal form, which you will see, but we are going to work on converting fractions, decimals, and percents on Friday. So just to give you a heads up of what you should be ready for. When you fold up your foldable, it will be a diamond shape, and you'll just paste it right into your notebook with the corners towards the center. And when it's opened, it should have those 4 problems with kind of the folds here where those gray lines are. So let's look at problem number 1 together. Which represents the perimeter of the rectangle? And it gives you 4 equations here that you need to think about. Well, just for our own sake, let's make sure that we know that this line here is an x, right? So I have a rectangle, and what do I know about rectangles? Well, rectangles have opposite sides that are equivalent. So I can immediately say what the side lengths of the remaining 2 sides are. And the perimeter means the distance all the way around the shape. So starting at one point, going all the way around the shape, that would be the perimeter. So I need to find the sum of all the side lengths around the rectangle. So obviously the most simple way to do this is to say 5x minus 2 plus 5x minus 2 plus x plus x. But none of these equations that are given to us in options A, B, C, or D are really written in such a way. So what we're going to do is combine our like terms to simplify the expression as much as we possibly can, right? So we could start by saying 5x and 5x, and then the single x's over here. So 5x and 5x are 10 x's, plus an additional x is 11, plus one more, it would be 12. So 12x. Then I have some whole numbers or some constant terms, a -2 and a -2. So I'm going to add on to my expression here, -4. Again, I could take a look and see, do any of these equations match up to that simplest form? Not quite, right? Not yet. So I know there's a couple of things here that I was thinking about that would help us to figure out what the equations are. We know that we need 2 sides that are 5x minus 2, and we need 2 sides that are x. So that's another way to think about this expression. Do any of these options have us multiplying by 2? Well, definitely letter B does. And it looks like that is the only option, right? I have 2 times 5x minus 2 plus 2 x's. So letter B would be the correct choice for number 1. If you went through the other options, you could see that letter A only allows us to add up the side lengths that were given to us, not the opposite side lengths as well, so we wouldn't have a complete perimeter. Letter C has us multiplying 2 of the side lengths rather than adding them. And letter D includes 2 opposite sides, but only one of the shorter sides. We're going to need 2 x's in that option. So obviously letter B is our best choice. Number 2 says Mary spends $23 at a restaurant and wants to add a 15% tip. Which represents the total cost of the meal? So if we went through progressively in the multiple choice options, we could think to ourselves 23 times 1.15. Well, 1.15 would be 15 hundredths, which is in fact 15%. So multiplying $23 by 1, which is the identity itself, and 15% should give us the total cost of the entire meal. Another option would be to multiply 23 just by the 15% and then add $23, which is the cost of the meal, back after the fact. You could do this. Unfortunately, this 15 was not given to us in decimal form, right? It needs to be 15/100ths, not a whole number 15. Again, in letter C, we're having an issue with where the decimal is placed. It should really be before the 1. Finally, letter D asks us to take the $23 cost of the meal and add 15/100ths, which isn't quite true. I need 15/100ths of the $23. So the only possible choice here would be letter A. And you can test out this theory yourself and think, okay, so if I paid $23 for a meal and I wanted to leave a 15% tip, a 10% tip would be 3, right? If I move my decimal place one place to the left, I would have a 10%, which would be $2, and 30 cents would be 10%. So 5% would be $1.15. So adding both of those amounts to my $23 total would give me $26.45. If I went back and double checked, you think about this, well, $23 and adding a 15% tip, it makes sense that it would be about $26. It sounds like a reasonable answer. Next, we'll move on to number 3. Number 3 says a store is having a 25% off sale. If a shirt originally costs $18, what would be the cost of the shirt after the discount? So thinking about the equations, there are a few things that I can do. I can think about the cost of the shirt after the discount by either removing the 25% or just taking into fact that the shirt is going to be 75% of the original cost. So there's a few ways to do this. It looks like letter A is not quite clear because even though it has me removing 25% or 25/100ths, it's not 25% of the $18. It's just 0.25, which would be $17.75, which is not 25% of the $18. So letter B definitely has me taking what is 25% of $18, but then it adds back the $18. So 25% of $18 plus $18 would almost be like adding a tax or a tip onto the price of the shirt rather than taking off a discount. Letter C has me thinking about what's 75% of the cost of the shirt and then removing $18, which has me removing too much information twice. And so letter D seems to be our only option where it thinks about what would be 75% of the cost of the shirt. If it was 25% off, what would it be remaining? And if you do this out and you think about, okay, well, what would be 75%? 75% would be the same as 3/4. So 18 times 3 would be 54/4. And if I simplify that out, I'm going to get $16. Is that correct? I'm sorry, more like $13. And some kind of change, which seems to be about 75% the cost of the shirt. If the shirt was originally $18 and it's 25% off, it's about $13. Lastly, number 4, which represents the area of the rectangle? Which expression is going to represent the area? Again, this is an x. We know that area of a rectangle is equal to the side lengths multiplied together, length times width. So 5x minus 2 times x. We could write this as a distributive property. So this letter A makes a lot of sense having the x on the outside of the parentheses, 5x plus 2, except it does have a plus where our side length is a minus 2. So moving on, 2 times the 5x minus 2 plus 2x is actually the formula for perimeter. So we have to pay attention. This has some tricky answers for us. Letter C says 5x minus 2 times x, which is very similar to what we wrote. So we'll keep that thinking. And letter D, again, is just more of an expanded form of the perimeter. There are 2 lengths and 2 widths all being added together to find the distance around the rectangle. So our final answer should be letter C. These are 4 pretty unique problems. They talk about real-world representations of equations, and it's easy to see how writing the equation incorrectly can really lead you to some different answers and things that you're not really looking for. So it's really important when you're setting up a problem to write an equation in a way that's going to give you the information you're seeking. Make sure you work on your proof. It says the store is having a 25% off sale. If a shirt originally cost $18, what would be the cost of the shirt after the discount? Please show your work. I know that this is a problem that we've done above, but I want to see how you do in justifying what the true answer should be. You should explain this in a sentence or 2. Enjoy the rest of your afternoon. I hope you don't get snowed in, and I'm really hoping to see you tomorrow.